Hello students, today we will solve one more question, and this question is based on electric flux and the Gauss's law. So here we will use Gauss's law. Along with that we will try to find the electric flux in the given question. So the question goes like this. An electric field is uniform and in the positive x direction for positive x, and uniform with the same magnitude but in the negative direction, negative x direction for negative x. It is given that E equals to 200 I Newton per Coulomb for x equals to 0 and E equals to minus 200 I Newton per Coulomb for x which is smaller than 0. At right circular cylinder of length 20 cm and radius 5 cm has its center at the origin and its axis along the x-axis, so that one face is at x equals to plus 10 cm and the other is at x equals to minus 10 cm. What is the net outward flux through each flat surface or flat face? B. What is flux through the side of the cylinder? C. What is the net outward flux through the cylinder? D. What is the net charge inside the cylinder? So, understanding the question, we will make one cylinder. This is our cylinder. Length of the cylinder is given to be 20 centimeter. Length of the cylinder is given 20 centimeter and the radius of the cylinder is given 5 centimeter. 5 centimeter. Now this center of this cylinder, this is the midpoint of the cylinder and this is center O, is at origin of the cylinder. This is origin. We can take it as x-axis, y-axis. Now there are three surfaces or three faces at which we need to find the flux. So this one is the phase 1. Phase 1. Which one is phase 1? This one is phase 1. This one is phase 2. Phase 2. And the other one is this curved surface area, which will work as our phase 3. This curved surface area. Phase 3. So, phase 1 equals to phase 2. Both are circular in nature. Circular in nature. Phase 3 is the curved surface area of cylinder. Curved surface area of given cylinder. Now, electric flux will come out from the surface 1 like this. This is electric field lines. Electric field lines coming out from the surface 1, and the vector of area for phase 1 will also direct in the same direction. In this direction, this del S will be directing. Similarly, when we will look over here, in this case phase 2, E will be in this direction, electric field lines will come out from here like this, and our surface area vector will also be in this direction, along the same direction. Now, what will be the case for phase 3? For the phase 3, surface area vector will be upwards. Surface area vector will be upwards, but the electric field lines will move parallel to the curved surface area. E will be here parallel. Now, what will be the scenario when we will calculate this flux for this field, this phase and this phase? So all these fluxes we need to calculate. The first thing which is given in our question is, we will summarize what the question has provided us. They have told us our electric field in the whole cylinder, everywhere, at this point, this point, this point, this point, this, or here, everywhere, at each and every point in this cylinder, our electric field is uniform. Electric field is uniform. Secondly, when x is greater than 0, that implies x will have positive values. At that point, electric field is also positive. Similarly, when our x is small than 0, x have negative values, our electric field is also negative. As you can see the numeral values, E for x greater than 0 is 200 I Newton per coulomb. E for x smaller than 0 is minus 200 I Newton per coulomb. Now our cylinder is right circular. Right circular cylinders are the cylinders who make 90 degree of angle with radius and the median line. Okay, with radius and the median line. Here length of the cylinder is given 20 centimeter. Radius of the cylinder is given 5 centimeter, which we have seen. This is 20 centimeter. From here, this is 10 centimeter, and from here, this is 10 centimeter. If this is origin, what do you think is the value over here at this point? It is plus 10. On x-axis it will be plus 10, and on x-axis it will be minus 10. See, center at the origin along x-axis, one face at plus 10 centimeter and other at minus 10 centimeter. So this whole thing is information provided in the question. Information provided in question. Whenever you solve a question, it is very much necessary. Our first step should be to write down what the question provided us, so that we can analyze the given information and write up the solution for the given problem. So our first problem was to find the net outward flux. Net outward flux will be from this surface and from the curved surface area of cylinder. So we will name this as F1 phase, this one as F2 phase, and what we know is that they are asking us flux. What is the formula for flux? Flux equals to electric field into given surface area. Electric field into area. It's not into, it's a dot product. So flux is denoted by xi equals to E vector dot product S vector. Now removing the dot product, it will be E del S cos theta. Now see phase 1, surface area and electric field both are parallel and in same direction. So what do you think is the value of angle between them? Angle between them is 0 degrees. Similarly, for phase 2, what we are having, E and del S are parallel, same direction, and hence theta is 0 degree. So what is the value of cos 0? Cos 0 equals to 1. For both the cases, xi will be E del S for phase 1 equals to xi for phase 2. Okay, it will be same. Now if we will substitute the value of E, we will get a difference in xi of phase 1 and xi of phase 2, the flux of phase 1 and flux of phase 2. How are we going to get the difference? We will see here in this solution. Xi 1 represents flux on phase 1, on this phase. Okay. E in E dot del S, E's value is minus 200 I is there, so I goes along positive x direction, I cap goes along positive x direction on the axis, whereas what is the direction of del S for the phase 1? It is along the negative x direction. So as these two are in opposite directions, when the dot product is taken for I dot del S, the product will turn as minus of del S. So this whole system will give you minus del S. This minus and this minus will sum up to make addition. So what we will get? Plus 200 into area vector, plus 200 into area vector. Now what is the area of F1? Phase 1. What is the area of phase 1? Phase 1 is circular. So area of a circle is given by pi r square. Pi's value we know, it is 3.14 into r. R's value is given as 5 centimeter. So 5 centimeter converted into meter, what will be it? It is 0.05 meter. So 0.05 the whole square. This is the area of phase 1. So 200 into pi into 0.05 the whole square, and for the phase 1 electric flux we received is 1.57 Newton meter square per coulomb. Similarly on the right phase, here in this case E and del S are parallel, and therefore this flux at the right is given as E del S. Similar in this way, our value is 200 I dot del S. Here in phase 2 del S is in this direction, I is also in this direction. So when we took the dot product, it comes out to be positive. Overall value is also positive. Hence we will get the same answer as flux of left phase, as the flux of F1. So this is the outward flux. there will not be any flux provided by the curved surface area. This we will see in this B option. Okay. So flux to the side of cylinder. What is the difference between option A, the question A, question B and question C is that in A they have asked us from the flat surface, from flat faces, not from the curved surface. Hence we did not introduce this. Now in the B they are asking to the side of cylinder. Side implies this part. This is the side of the cylinder. Now we have to calculate the flux coming out through this. In this case, what is the thing I have explained in the previous slide, in the previous diagram? You can check cylinder, in the side of the cylinder, E is perpendicular to del S, the area vector. Electric field lines are perpendicular to surface area vector, surface area. Hence, dot product of E and del S comes out to be 0. How? See, E dot del S, we are removing dot, it will be E del S cos theta. As these are perpendicular to each other, what is the value of theta? It is 90 degree. So it will become E del S cos 90 degree. Now what is the value of cos 90 degree? It is 0. So anything multiplied with 0 will give you solution is 0. So the flux on the side of cylinder will be 0. Now see, she says net outward flux. Net outward flux implies from the circular end 1, from the circular end 2 and from the curved surface area. From the option A, we can get xi at circular end 1, xi at circular end 2, and from the option or the question B, okay, option of question B, we can get surface, curved surface areas flux. So over this area, the flux is 0 because theta was 90 degree, E del S was E del S cos theta, theta was 90 and hence it became 0. And for this and this, these are in the same direction like this and like this. So we get 1.57 Newton meter square per coulomb. Similarly, for the other one also we get 1.57 Newton meter square per coulomb. Adding it up, we get the total flux to be 3.14 Newton meter square per coulomb. This is the total flux through the cylinder, total flux or the net flux. So how can we find the net flux in a given system? From taking the flux from side A, B, C, D and all, whatever sides that system is having, from all these sides what is the flux, if we will find, we can find the total flux on that system. Now the third, last and the fourth question was to find out the net charge inside the cylinder. So it will be, we know from the Gauss's law, this one, flux equals to 1 by epsilon naught times the charge present in that system. Okay, this is a system containing charge Q. So the flux coming out will be 1 by epsilon naught into the charge Q. So applying the same, we will get like this is known value, this is known value, unknown is this is unknown value. So Q equals to xi into epsilon naught. Value of xi will come from here, it is 3.14 Newton meter square per coulomb. Similarly, value of epsilon naught will come from this. This is a static value, it's a constant, okay, 8.854 into 10 to the power minus 12. We will multiply both and we will get answer as 2.78 into 10 to the power minus 11 coulomb. So this is the charge contained by the cylinder. Charge contained in the cylinder. So this is the answer, required answer, which we were trying to find out in this slide. So we get the flux from the flat surfaces, flux from the curved surface, net flux, and the total charge in the last option. So we have used the formula of electric flux and Gauss's law here. We have applied these two things in this question to get our desired answer for the question. So that's how we have completed the task of finding answer here, and that's all for today's class. Have a good day.